Okay, so last section we're going to look at, same section as yesterday, 4.1, just the last half of it. So we're going to be dealing with right triangles, but today we're going to solve them. Okay, to solve a right triangle means to figure out basically 6 things. How long is each side? And what's the measure of each angle? Now, since we're dealing with a right triangle, there's something that you already know in every problem. What do you already know if you're dealing with a right triangle? It has an angle with 90. So every single problem that we do today, they're all going to have an angle of 90. That's the only thing they're going to have in common. All right, so that's one piece of information you already know when you're starting these problems. But to solve a triangle, I have to give you 2 other pieces of information. All right. So to solve a triangle, you have to start with 3 pieces of information. The fact that you have a 90, and there's actually 2 cases. Okay. One case is, in addition to the 90, I could give you a side and one of the acute angles. So that you'd know 3 things: the 90, the length of a side, and the measure of one of the other smaller angles. Or, instead of giving you a side and an angle, I could give you both sides. So you'd know that it has a 90, and you'd know 2 out of 3 of the sides. Depending on which case you have, it kind of changes a little bit how you go about solving it. One of these cases you have to use inverse trig for. That's what we learned on Monday and Tuesday. The other case you don't. Now, I didn't put up here 2 angles. How come that wouldn't be helpful if you knew you had a 90 and you knew the other 2 angles? Yeah, because if you don't know any sides, you wouldn't be able to figure out the size of the triangle. Like, if I said to you, here's a triangle with a 90, 20, and a 70. Tell me how long each side is. Well, you can't, because you could just take that triangle and let's make a copy of it, and you could just go like this. All those angles are exactly the same now. They're still 90, 20, and 70. It's just you shrunk it down. So if all you know is the angles, you could find a triangle that's similar, but you couldn't actually find one that and know the sides. All right. So that's why you'll always have one of those 2 cases. All right, since we're going to be using trig functions today, trig functions have the words opposite, adjacent, and hypotenuse. It's kind of helpful to have a picture so you can see like what's opposite, what's adjacent. After you've done a lot of these, you can kind of visualize it in your head. But I think at first it's helpful just to have a sketch so you can say, okay, this is across from this, that's across from that, this is next to this. Right, it's just easier to see it, especially in a word problem. So we'll make a sketch with the information that's given. Keep in mind the sketch is not to scale. What's important in the sketch is that you put the right letter across from the right angle. And we talked about that yesterday. A across from alpha, B across from beta, C is the hypotenuse. That's how you always want to set it up. And then what we'll do is we'll kind of organize all the information that they give us in the problem and then what we're trying to find in a table. So you don't have to make a table if you don't want to. But the table is just there to kind of organize everything that we know and what we don't know. Okay, so just a reminder again about that way the triangle is going to look. The 3 letters that I used for the sides, I just said them a couple minutes ago, but what are they again? Not the angles, the sides. We're going to do the angles next. Yeah, what would you call the hypotenuse? What do we usually call it? C. And then what do we call the other two legs? Doesn't matter which one goes where. What does matter now is that we label the angles correctly. Well, you don't need to label the 90. It's already a 90. So you don't have to give it another name. But you got to give a name to the one in the lower right and the one at the top. What's the one in the lower right, since it's across from A? Not theta. That is a Greek letter we use for angles a lot. But we don't use it here. We use alpha. Just because A and alpha starts with A. So that's how we can remember it. A, alpha. B, beta. Okay. So those, that's the diagram that we're always going to use. We're just going to fill in whatever they give us. Okay. So it says solve the triangle. So this is the case where they're giving you a side and an angle. That's this case right there. A side and an angle. Right, so let's sketch it. I'm basically going to take the picture I have right up above, and I'm just going to erase B and alpha and fill in 2 and 40. Okay. So let's draw that out. So there's my 90. B is 2. Alpha is 40. And the rest of it, just leave with the labels that you don't have. Okay, so we don't know A, we don't know C, and we don't know beta. So the picture is there so you can visualize what's across and what's next to what. Now we're going to make a table, and this just makes it easy for me, so when I'm grading it, I can see all your answers kind of, nicely organized. So the table is going to look like that. I just put the 3 sides in one column, and I put 3 angles in the other column. I put boxes around the things that I don't know. So A, I don't know. C, I don't know. Beta, I don't know. All right, now, when you have a right angle in a triangle, you pretty much can solve for, in this case, you could find anything you want first. It's not like you have to find one thing and then use that to get the next thing. No, you can find any one of those 3 boxes first. Which one do you think would be the quickest to find? Beta. Yeah, beta is going to be the quickest because we already have 2 of the other angles and we know they all add up to what? They all add up to 180. So we know these 2 have to add up to 90. So what's beta? It's 50. All right, so you got beta. Now, to find A and C, what you have to do is basically pick one of the acute angles and use that as your perspective, kind of like your reference point. So we have a choice. We know alpha and we know beta, but one of these angles would definitely be a better choice to pick. Does anyone think they know which one I would go with? And there's a pretty important reason why. Yep.
Beta.
Which one?
Beta.
Okay, why would you go with beta?
Because it already has a link for the opposite. The opposites too.
Okay, so when we study problems that don't have right angles in them, that's going to be important that we know the side in the row with the angle. But for right triangles, it's not important that you have this side. It's okay that it's missing. So that's not really the reason why we would want to pick beta in this case. But that is going to be important for something we do in a couple weeks. So hang on to that thought for a couple weeks. Anyone have any other thoughts about which angle I would pick? Because you can pick either one and do this problem correctly. Yeah?
Alpha?
I would definitely pick alpha. And there's a pretty important reason why. Why do you think I would pick alpha? Yeah?
Because it already has a side.
Because it already has a side.
Like a side, like a label side. I don't know.
So I agree with alpha, but anybody have a really good reason why? Yeah?
Is it because it's adjacent to?
It doesn't have to do with its position at all. So it doesn't have anything to do with where it's located. Why do you think I would pick alpha? It doesn't matter where it is. Yep.
Does it have something to do with like complementary angles and
Well, alpha and beta are complementary, which is true, but no, doesn't have anything to do with the fact that it's complementary. It's a very basic reason why I would pick alpha.
it's a smaller number?
Okay, it is a smaller number, that's a basic reason, but I'm going to use a calculator, so the calculator doesn't care how big the number is. But, anyone else have another guess why I would pick alpha?
Is this the only given angle?
It was what?
Is this the only given angle?
Why would I want to pick an angle that was given?
You know you're right.
Because I know it's right. Alright? If I pick beta, which is correct in this case, but let's say I got beta wrong, and then I use it to figure out A. What's going to happen to A?
It's gonna be wrong.
A is going to be wrong. And then if I use A to find C, then C is going to be wrong. Everything's going to be wrong. So when we solve a problem like this, we're going to try not to use anything we calculate to find anything else. So that way, if we make a mistake on one thing, it would only mess up that one thing. It wouldn't mess up anything else. All right, so we've got beta. We calculated it. Now forget about it. We're not going to use beta for the rest of the problem. We're going to use alpha. Okay, so I'm going to circle. Everything that we do when we talk about opposite and adjacent, it's going to be from the perspective of the 40. Okay? Not beta. And now we can find A or we can find C. Doesn't matter which one we do first. So which one do you want to try first?
A.
A. All right. So I'm going to circle the one we want to find. And whenever you're trying to solve for something, you have to use three pieces of information. Use the two things that were given, and then the thing that you want to find. So you're always going to be given two things. Circle them, and then circle the thing you want to find. Now, we've learned about 6 trig functions: sine, cosine, tangent, secant, cosecant, cotangent. We're always going to use sine, cosine, or tangent today. We're not going to use secant, cosecant, or cotangent for anything. Why do you think I'm picking sine, cosine, and tangent? We could use the other ones, but they're more work. How come?
Those are the most basic ones.
Okay, so they're the most basic ones. What else?
Oh, they're the only ones on the calculator.
They're the only ones on the calculator. No matter what calculator you're using, you're never going to see a button. Well, maybe they make one, but I don't have one. I don't have one on the computer. I don't have one for you to borrow that has SEC, CSC, or CO2. There's no buttons for those. So it's easier to use with this tool, it's easier to use the ones you have buttons for. So sine, cosine, or tangent. All right, so now we're going to find A. So to find A, we have to pick one of those 3 trig functions. How do we pick which one? Well, we have to look at the side that we know, figure out what its name is, and figure out the side that we want to know, and figure out what its name is. When I say name, you have 3 choices: opposite, adjacent, hypotenuse. Let's start with the 2. From the perspective of the 40, is the 2 opposite, adjacent, or hypotenuse? It's adjacent. It's right next to the 40. So we've got adjacent, and we're trying to find A. Well, it's not the adjacent. That's 2. Is A the opposite or the hypotenuse?
Opposite.
It's opposite. So you're trying to figure out a trig function that has those 2 in it. And out of sine, cosine, and tangent, there's only one. Which trig function has opposite and adjacent? Tangent. Yep. So that's the function you need to use. So it's tangent. And then it's always the tangent of your angle. We're doing the 40 degrees. Now remember, does that mean multiply? No, right? When you have a word and then parentheses like that, it just means this is the number that you plug into the tangent function. It's not a multiplication problem. You can't multiply a word that doesn't make sense. All right, so it's the tangent of 40 equals, and now tangent is, well, we want opposite over adjacent. All right, so when I asked you the question, we kind of did it in the other order, but remember, tangent is opposite over adjacent. If you did this, that's cotangent. All right, these are the 2 sides that you want. We just want to do opposite over adjacent because that's what we have a button for. So what side is opposite A? Yeah, let me try again. What side is opposite 40?
A.
A, yeah. Opposite over, what side is adjacent to 40? 2. Again, you're not wrong if you did adjacent over opposite and flipped it, but now you have to type that in on the calculator and you don't have a button for it. Okay. So we'll do opposite over adjacent. Now we want to get A by itself. So we just have to move the 2 to the other side. William, how do I move the 2 to the other side?
Multiplication.
Yep, multiply. And what are you going to multiply by on each side?
2.
2. Times 2, that's gone, times 2. Divided by 2 times 2. Those are opposite operations. They cancel out. And there is your answer for A. We need to type that in and we'll round it off. That's your answer for A. 2 tangent 40. Actually, can somebody pronounce what's in that box for me? How do you read that?
2 tangent 40.
Can you be a little more specific?
Degrees.
Yes. Tangent 40 degrees. So when you type this in on your calculator, there are going to be problems on the test, maybe from earlier sections that might have radians. When you get to these kind of problems, we're going to use degrees. So make sure you change your mode back. Okay, and I've shown you, I think I've shown you how to change the mode on my calculators. We're going to press the DRG button. Okay. And so now we just type it in. 2 tan 40. All right, so we get about 1.678. 1.678. Okay. So, one more thing, and then I'm done the problem. So, I've got A and I've got B, and it's a right triangle. So how could you get C? You could use the Pythagorean Theorem. But why do you think I would recommend not to do that?
Doesn't have a nice root.
All right, so we don't have a nice answer, so this is rounded. That's one reason why we don't want to use it. What's another reason, an even stronger reason why we might not want to use that?
We only want to use things that were given.
Right, why do we only want to use things that were given?
Because if it's wrong, then C is going to be wrong.
Right. If this is totally wrong, forget if it's even rounded. If it's just a totally wrong number and you use it, then C is going to come out wrong. So we're going to find C the same way we found A. Okay. This time what I'll do is I'll just circle them in a different color. We're still going to use the 40 because that was given. Still going to use the 2. That was given. Except now we want to find C. So focus on what's in green. We already know that the side that's 2 is adjacent. We're using that side again. What about side C? That's the hypotenuse. Okay. 2 is the side we know. C is the side we want to know. And those are called adjacent and hypotenuse. So now we've got to think of a trig function that has adjacent and hypotenuse. It's not tangent, because that's opposite and adjacent. Cosine. Adjacent and hypotenuse. Okay, so let's set that up. Cosine, and what's going to go in the parentheses? 40. You always put your angle, and remember that does not mean multiplication at all. It's just the thing you're going to take the cosine of in a minute. Equals adjacent over hypotenuse. 2 over C. Okay, so we're going to kind of do the same thing we did last time. First thing you want to do is get rid of that fraction on the right-hand side. So you're going to put C on the left. So Jake, how could I move the C to the other side?
C equals cosine 40 degrees. And then 2 would just be the numerator.
Well, what operation do I have right here?
Division.
Division. What's the opposite of division?
Multiplication.
Multiplication. So we're going to multiply. And what's the thing that we're trying to get rid of right now?
The C.
The C. So we're going to multiply both sides by C. Times C times C. So now we've got C cosine 40 equals 2. Is there multiplication on the left-hand side now? Yes, there is. That means C times the cosine of 40. Okay. And now I've got one more step. This equation is kind of like this. A letter times a number equals a number. Letter times a number equals a number. How would we get C by itself? What would be my last step? Yep. Yeah. Divide both sides by cosine 40. Cosine 40. That's gone. And look at what you get. 2 over cosine 40. I'll type that in a second. Look at what you started with. I'm not gonna put a box around it. I'll just go like this because I don't want you to think that's the answer. But that wavy box is what you started with. And look at what you ended up with. If you wanted to go from what we started with to what we ended with, does anybody see what you could have just done in one step? Yeah?
I was gonna ask, like, why didn't you just divide both sides by 2? But that's not what you did.
Well, if you divided both sides by 2, you would have this.
Yeah.
Cosine 40 over 2
Equals C.
1 over C.
Oh! Yeah, I didn't do that. Okay.
Because if you divided by 2, you'd get rid of the numerator, but you'd still leave the denominator.
Okay.
I mean, then you have a proportion. You could cross multiply or something like that,
Okay.
but it's just not the quickest way. So, does anybody see visually what happened? Look at the wavy box. Look at the final answer. What ended up happening? I just wanted to kind of describe it visually without any math.
Switch the cosine to C.
Yeah, all that happened was the C and the cosine 40 switched places. You can always do that. If you have a problem like that, where you have one thing on one side and a fraction on the other, you can always just switch these two things. That always works. So C equals B over A. You can always switch them. So from now on, when I get this kind of pattern, where I have a number on the left and a variable in the bottom, I'm just going to switch the number on the left and the variable in the bottom. The reason why? We just went through it. That's the pattern. It just works that way. Okay? All right, let's type that in and see what we got. 2 divided by cosine 40. So we get 2.611. Now, a couple things you can check here if you have time on the test to see if you got it right. Check to make sure the biggest side is always across from the biggest angle. That should always happen. And the smallest side should always be with the smallest angle. If that doesn't happen, something went wrong. The other thing you can check is if you add any two sides together in a triangle, it has to be bigger than the third side. That's a rule about triangles. So if I add A and B, I get 3.6. That's bigger than 2.6. If I add B and C, that's 4.6. That's bigger than 1.6. And if I add A and C together, I get, what's that, like 4.2, which is bigger than B. All right, so any two sides added together have to be bigger than the third. All right, so you can check that. The other thing you can check is this. Let's do 1.678 squared plus 2 squared. I get 6.815. When I do 2.611 squared, what should I get? Yeah, what am I doing right now? I'm doing the Pythagorean Theorem. Now, if you think, well, wait, he said don't use it. I'm not using it to find my answer. I'm just using it to check what I already have. So a squared plus b squared added up to 6.816. C squared is 6.817. They're not exactly the same. So does that mean I did something wrong? No. Why not?
Because they're rounded.
Because they're rounded. I mean, they're very close. 6.816, 6.817. That's very, very close. So if they come out within 1/1000, that's a good way to check that you did it right. Any question on that problem? So let's try one more of that type, and then we'll do one of the other type. Okay, so take a couple minutes, see if you can figure out B, C, and alpha. Again, I might make a sketch first, just so you can see what's across and what's next to what. And remember, you can find anything you want in any order you want. I just usually do the angle first because I think it's the quickest. But if you want to do the angle last, you can do it last. All right. So again, first thing I usually just try to do is get the angle, get that out of the way, and then and that's done. Jose, what's the angle going to be here? Well, the angle that was given was 20. What about alpha?
Oh, that's 70.
70, yep. Good. So if you add all those up, they will all add up to 180. All right. So we got that. You can kind of do that part without a sketch. For B and C, I really would make the sketch. So here's my triangle. I'm going to put A. Again, I'm just going to leave alpha. I'm just going to put what was given, right, in my diagram. That way I don't accidentally use something that I found. So A, alpha, B, beta, and C. All right, the 6 and the 20, I can circle both of those because I'm going to use them every time. Now it's just a matter if I want to find B or I want to find C. Devin, which one do you want to try for next?
Let's do B.
B, okay. So we're going to find B. So I'm going to circle B. You don't have to circle it. If you want to circle it, you can. It's up to you. But now I got to figure out the names of the two sides that I have. Okay, opposite, adjacent, hypotenuse. So Jasmine, from the perspective of the 20, what's side B?
Opposite.
Yep, that's opposite. just going to write that down. And William, what about the side that's 6?
Jason.
Adjacent. So out of our 3 trig functions, which one has opposite and adjacent? Tangent. Yep. So it's going to be the tangent of, what am I going to put in the parentheses? 20 degrees. Tangent of 20 equals, and now put opposite over adjacent. Kyle, which side is opposite here?
B.
B. And which side is adjacent?
6.
Perfect. Yep. And now this is the type where all you have to do is multiply both sides by 6. 6 tan 20 equals B. Okay, just type that in and see what you get. So 6 tan 20. You should have gotten about 2.184. Anybody else get 2.184? Yep. Good. And now let's do C. All right, so I'm going to find C. I know it's going to be a fraction on the other side, so I'll set that up. I know I'm going to have a trig function with parentheses, so I'll just set up everything I can, and now I'll fill in the rest. All right. So C. What side am I using now that I didn't use last time? Come on.
What side?
Yeah, what side am I using this time that I didn't use before?
Not sure.
Well, what 2 sides did we just use in the last part? So in this triangle, we used 2 out of 3 of the sides when we did the last calculation. Which 2 were in the calculation?
A, B.
Yeah. So the 6, which was A, and the B. So what side am I going to solve for now?
C.
C, and that's the hypotenuse, exactly. So we need a trig function that has hypotenuse, and we want to still stick with the one that's given. So 6, 20, and C. What trig function has adjacent and hypotenuse in it? Cosine. Yep. So it's going to be the cosine of 20 equals, and now fill in adjacent over hypotenuse. 6 over C. So you can see sometimes the letter ends up in the top of the fraction, sometimes it ends up in the bottom. It just depends on the problem. And now what's the shortcut here to get C by itself? Just switch the cosine and the C. Yep. So 6 over cosine 20. And did anybody type that in and have the answer? Yeah, would you go ahead? Yeah, definitely. Yeah.
6.385.
6.385. All right. You got the same one? All right. So let me look at it quick. Biggest side with the biggest angle. Yep. Smallest side is with the smallest angle. So it doesn't look like anything is obviously wrong. Right. So any questions on that? All right. Let's look at this one. What's different here?
You got 2 sides now.
Yes, this is the second case. We're just going to do one of these. You have 2 sides. So what you can't do this time is you cannot get the third angle right away because you're missing 2, right? I mean, you can get it, but it's not quick, right? It's a little bit longer. This time, something else is going to be quick.
Getting C.
Which one?
Getting the echelon.
Yeah, getting C. Now, what do you think I'm going to be okay with you using this time to get C, but I wasn't okay before? Pythagorean Theorem is fine. Why am I okay with it this time?
Because we have 2 of the given ones.
Right. Everything that you plug into that theorem is given. You're not using anything you found. So let's find C. A squared plus B squared equals C squared. 3 squared is
9.
9. 2 squared?
4.
And 9 and 4? 13. Usually with these kind of problems, they round it off. Okay? With the kind of stuff we did yesterday, like in the homework, I said if you get a square root in the bottom, you need to fix it. Those kinds of problems, they usually leave square roots in the answer. This problem, since you're actually asking how long is the side, we'll round it off. So let's just do the square root of 13, which is about 3.606. We're good? We're okay with that? Okay, so 3.606. Okay. That part we can kind of do without the diagram because it doesn't really involve opposite and adjacent. The rest of it, I would make a diagram. 3, 2, alpha, beta, c. Didn't put anything in the diagram that I found. Okay. So, always circle the two things you were given. So we're definitely going to use the 3 and the 2. And now we can pick alpha or beta. Doesn't matter. Kayla, which one do you want to do first?
Alpha.
Alpha. All right, so we're going to do alpha first. And now you go through the exact same steps. Look at the sides that you know. Figure out the names of them. Are they opposite, adjacent, or hypotenuse? And then pick the correct trig function. So the side that's 3, what's the name of that side?
Opposite.
Opposite. Remember, everything in this part is from the perspective of alpha because that's what we're finding. So opposite. And what about the 2?
Adjacent.
Adjacent. We have the opposite, we have the adjacent. Which trig function involves those two? Tangent. Yep. So we're going to do tangent. What's going to go in parentheses? The tangent of alpha. This is the first time we've ever had a variable inside the trig function. Okay? So tangent of alpha equals opposite over adjacent, 3 over 2. All right, so now the goal is to get alpha by itself. What's preventing alpha from being by itself right now? Tangent. Tangent is a function. The only way to get rid of a function is with a function that undoes it. You can't get rid of a function using addition, subtraction, multiplication, division. So what function gets rid of tangent?
Inverse tangent.
Inverse tangent. And this is what we did yesterday. Remember we had those formulas on the board like 4a, 4b, 6a, 6b. Inverse tangent of regular tangent, gone. They cancel out. But if you do it on the left, you also have to take the inverse tangent of what's on the right. Now remember, there's no multiplication on the right-hand side. It's just the inverse tangent of 3 over 2. Okay. So let's type that in. How do I get to inverse tangent again? Second, yeah. Second tangent, 3 over 2. We get an angle of 56.3, well, if we round it, it's 310. Okay, it rounds up to 310. Okay, so I'm going to put it up in the box. 56.310. Now, what I usually do here, just kind of a quick thing, is the other answer should come out to 90 minus 56.31. The other answer should be 33.69, but I'm not going to write it down because the way I just found it, I used something I calculated. But I'm going to keep that number in the back of my mind. Okay, 33.69. Okay, remember that. Let's see if that's what we get when we find beta. All right, so now I'm going to circle beta, the 3, and the 2. Now your perspective has changed. Okay? This is the first time we've actually switched the angle that we're using. Let's see.
What's your focus?
I won't switch the angle again. So we switched the angle, different perspective. What's the name of the side that's 2 now?
Opposite.
Now that's opposite. What about the side that's 3?
Adjacent.
Now that's the adjacent. But it's still opposite and adjacent. So it's still tangent, but the opposite and adjacent have switched. Okay? So let's do that. So it's going to be tangent. This time it's beta. And put your opposite over your adjacent. 2 over 3 instead of 3 over 2. It flipped. And same thing I did last time. How am I going to get beta by itself? Take the inverse tangent. So let's type that in. And if I get 33.69, then I'm guaranteed it's right because then I get the same answer 2 different ways. Let's see. Inverse tangent of 2/3, 33.69. Yep. So if you get the same answer 2 different ways, it's pretty sure it's right. All right. Oops. That was weird. Maybe the board caught what you were sneezing about. I don't know. All right. Any questions on?
Can you scroll back down?
Yeah. Okay, so the actual arithmetic here, it's not really that much. It's just making sure you use the right trig function. Okay, so the last one we're going to finish up with is a word problem. Okay, so we'll finish up with that. That's another one that's the same as the type we just did, so I'm going to skip over that one. And let's do this one. So, it says that you're leaning a 20-foot ladder against the house, and they tell you the angle between the ladder and the house is 17 degrees. How high will the top of the ladder reach? Now, if you were standing on the ladder, you could probably reach higher than the top of the ladder because you have height. But all I really want to know is how high will the top of the ladder be? Okay. Now, whenever we have a word problem, what was my suggestion? What's that? Okay, you can underline some of the keywords. What's going to be important there? Yep, 20 feet. Very important. The 17 degrees. And that's pretty much the only 2 important things, the 2 numbers. Now, what should we do with all that information to make it easier to kind of think about? Yep, let's draw it out. So first thing I need is the ground. And then we have a house. Or some kind of object over here that the ladder is leaning up against. So the ladder is leaning like that against the house. So I'm going to assume that that's a right angle. I'm drawing a little crooked. But the house, we're going to assume that it is a right angle. The 20 feet, what is that in my diagram really? It's the hypotenuse, right? It's the length of the ladder. And now it says the angle between the ladder and the house is 17 degrees. Where is the ladder and the house? Is that at the bottom or at the top? That's the top. So be careful if they say like the ladder in the ground versus the ladder in the house. Okay, so here's my triangle. And what am I basically trying to find in that triangle? The what? Which side? Well, we don't have to figure out how far that the ladder is from the house on the ground. They just want to know the what? How high? They want to know the height of the triangle. That's all they want. If they said how far is the base of the ladder from the house, then you'd want the bottom side. But they didn't ask for that. Okay. Here's your angle. Here's a side. Here's a side. Okay. 20 is the hypotenuse, so they already said that. What about A? Is that opposite or adjacent? Adjacent. It's right next to it. Which trig function has those two sides in it? Cosine. So the cosine of 17 degrees equals, and what's going to be my fraction on the other side? A over 20. And my last step? Multiply both sides by 20. So you've got 20 cosine 17. And if you put the ladder at that angle, it's not going to be able to reach 20 feet high because you put an angle on it. And it's going to reach about 19.13 feet. Okay, so that's like 19 feet and maybe an inch or two, roughly. Okay, any questions on that? All right, so that finishes up section 4.1. Okay, so homework tonight, it's the same page as the second page you had last night, 255. And it's odds. Okay, 31 to 39 odd, 43 and 47. And then 51 to 55 odd. We'll go over that in class tomorrow. I'll be after school tomorrow if you need extra help or you got to finish up the test. We'll do a review in class that'll focus mostly on section 4.1 that we did today. You'll have whatever time after the homework we have left, you'll have all that time to work on the review sheet, and that's the only homework tomorrow. So if you're absent and you want a copy of it early, just come see me later today. If you know you're going to be out, and I'll give you a copy of it. I just haven't made the copies yet. Okay?